Hi friends, welcome to Science. Today is Tuesday, April 28th. Let's have a quick flashback of what we've learned so far in science. Last week, we learned about magnets and static electricity. We learned that magnets either attract or repel objects. So remember, attract means to push together, and repel means to pull apart. Static electricity can attract and repel due to electrical charges. Today, we are going to explore more about magnets. So here is our target for today. I can describe the interaction between two magnets. So what this means is that we're going to describe or explain what happens between two magnets. Our second target is I can explore experiments to answer questions about what happened. So we'll be watching videos of experiments dealing with magnets, and we're going to answer questions together about what happened. So all about magnets. Last week, we learned a lot about magnets. This week, we'll be able to use what we learned to explore more about magnets. We are going to watch experiments happen between magnets. Then we are going to answer questions about what is happening to show what we know. So here's our first video about magnets. We're going to learn what magnets are attracted to. So let's go ahead and take a look. So the first one is iron, and magnets are attracted to iron, but they aren't attracted to aluminum, magnesium, or titanium. They're definitely not attracted to tin, but they are attracted to cobalt. They're not attracted to zinc, lead, or copper. They are attracted to nickel. They're not attracted to gold, silver, or platinum. So the only three metals they're attracted to are nickel, cobalt, and iron. So we saw in this video that magnets are attracted to metal. They're only attracted to three metals: iron, cobalt, and nickel. Now let's answer a quick question together. If I had an object made out of copper, would it be attracted to a magnet? Pause the video and think about it. You're right. No, magnets are not attracted to copper. If I had a ball made out of nickel, would my magnet be attracted to it? Think about it. What were the three metals that are attracted to magnets? Iron, cobalt, and nickel. It would be attracted to the magnet. Magnets are attracted to iron, nickel, and cobalt. Now let's watch this video. This video talks about how magnets react to each other. So the person is trying to put two like sides or like poles of a magnet together. However, you can see that the magnets are repelling each other. They're not sticking together. Now you can see that the magnets are attracted to each other. This is because the person in the video is placing the two opposite poles towards each other. Now let's watch a metallic ball be deflected by a magnet. This first one is a non-metallic ball. You can see that it went straight down the ramp. Here's the second one. It's a metallic ball goes to the side. This is because it's getting deflected by the magnet. Here's a magnet and the compass. You can see that the compass is attracted to the magnet. Now that the person uses the other pole, you can see that the compass is repelling against the magnet. So this video showed us how magnets react to each other. Opposite poles attract, and like poles repel. So let's answer a quick question. Why do you think the first ball went straight past the magnet when it rolled down the ramp? You can pause the video and try to answer that question. The reason the first ball went straight past the magnet was because it was non-metal. This means that there was no metal in the ball for the magnet to be attracted to. Let's learn a little bit about contact forces. A contact force is a force that acts upon an object when they are touching. When a magnet interacts with another magnet or metal that it is attracted to, the magnet does not need to touch the object. You could see this in the videos we watched. The magnet did not need to touch, they just needed to be close together and they would attract quickly together without touching. This shows that the magnets are not contact forces. Once an attracted object or another magnet is in the magnet's magnetic field, the object begins to move closer. Now let's answer another quick question. If an iron object is in the magnetic field of a magnet, does the magnet need to touch the iron object to be attracted? Take a second and think about it. All right, given what we know and saw in the experiment videos, we know that magnets are attracted to iron. We also learned that magnets are not a contact force. Therefore, if an iron object was in the magnetic field of the magnet, the object will move closer without touching. So let's go ahead and review our target. I can describe the interaction between two magnets. So this means that we are going to talk about what happens when you have two magnets. We saw this happen in two different videos. Our second target is I can explore experiments to answer questions about what happened. So today we watched 2 different types of experiments happen, and we were able to answer a lot of questions together. Now it is your turn. Answer the questions below. Comment what you think what would happen in the situations given. Next week, we'll have a quick recap of all of the information you learned about forces. Then you will complete an assessment to see if you have become a force expert. Great job today, friends, and I will talk to you next time.